Do you feel like passing out when you need to get a shot? Pay attention because there might be an alternative for you.
How can you get an injection without a needle? This is the University of the Netherlands.
Are you afraid of needles? If the answer is yes, please look away from the screen right now. How do you feel if I show you a picture of a visit to the dentist? Or a person receiving Botox treatment? Or receiving a tattoo? I don't fear needles myself, but it's known that about 30% of the population is afraid of needles. Now, that is a problem because we really need needles for many medical procedures. Think about vaccines, for example. Most are injected because you cannot swallow a vaccine, otherwise your digestive system will destroy it. Another example is treating diabetes, where you use needles on a daily basis to inject insulin to keep the glucose levels in check. The huge advantage of needles is that you can pin down precisely the area where you have to inject the medicine and how much fluid you need to get in. If we look at our skin, you can see that it consists of different layers. Some drugs work only if you inject them below the superficial layers of the skin, for example, in the muscle, but other medicines or drugs work better in the dermis, which is the second layer of the skin. As you can see, with the needle, you can reach almost all layers of the skin, particularly the deeper one. Needles are also easy to use, and they have been successful for decades at healing many diseases. However, there are downsides to needles besides fear. The first one is the chance of the doctor or the nurse of pricking their finger by mistake, and that is very risky if the patient has hepatitis or HIV. The second problem is environmental. When we use needles, we generate a lot of waste, and worldwide, we use each day 44 million needles. In principle, used needles should not be thrown away in the normal trash because it can harm people and contaminate our environment. Therefore, needles need to be collected and transported in special containers like we have there. So, is there really no other option than the scary old needle? Well, there are a few options, and in my opinion, the most exciting is what we call jet injection. It means that we create a liquid beam or jet that when fired with the right speed, it pierces through the skin. This might sound like science fiction to you, so allow me to explain you a little bit more about how it works. As energy source, we use portable lasers that allow us to create very thin liquid jets, no thicker than a human hair. As you can see in this image, the laser is used to heat up the liquid fluid containing the medicine. This liquid boils due to the heating effect of the laser, creating a bubble, and this bubble grows very fast and pushes the liquid out of the container with velocities of up to 360 kilometers per hour. And this jet punches through the skin. My team and I are working on a handheld device comparable to a pen in size. Let me show you how we think this technology will work in the future. So in this handheld device, we have the portable laser, and the medicine goes in this container. If you click this medicine container at the tip, then you just bring the injector close to the point where you need to give the medicine to the patient, press the laser button, and then you will deliver the medicine painless and very fast. Now, let's zoom closer and see how a real injection looks. We go to the lab and test our technique using fake skin or a gelatin, with which we reproduce the different skin layers. And to visualize the injection, we then bring a red color to make it easier for our cameras to take the images. In this video, you can see actually how the laser heats up the liquid, the bubble is formed, and the liquid is pushed out in this fast-traveling jet. Then this jet punches very deep into the fake skin. And all this happens in less than 1 millisecond. Please remember that a millisecond is 1,000th of a second, so that is very fast. All this is looking great, and we're making progress with the technology, but it's not easy to deliver a few nanoliters of medicine at the right spot every time. First of all, we need to get this jet in a very continuous straight line, Because, as you can see in this other video, if the jet is wobbly, it's not good, because it prevents some of the medicine from entering the right point into the skin. The second problem is the speed of the jet. If for some reason the jet is too slow, it might not pierce the skin, and then the consequence is that too little medicine is injected to the patient. If we generate the jet too fast, we might get too deep into the skin, and then the medicine is lost, and the treatment is very ineffective. Finally, the biggest challenge of all is to reach the right depth into the skin. And this is because everybody's skin is different. We all have different skin properties, and our skin changes from the part of our body as we age and with the environmental conditions, for example, with the change of seasons. In the summer, your skin is drier and more brittle than if you have well-hydrated skin, for example. To overcome all these challenges, we do research in our lab so that our device will work as required, adjusting each injection to reach the right depth, delivering the right volume needed by each person that needs the injection. You might ask yourself, does it hurt? Well, the good news for you is that such a small jet should be painless. Moreover, if we do it the right way, the skin should not get damaged in the process. If you recall that we use a red dye in our experiments to visualize the injection, we can see where we are delivering the liquid. And in this particular experiment, we have a tiny 1 millimeter spot, and we believe that probably you will not even feel that injection because it would be so fast and so small that you could compare it with the way that you don't feel a mosquito bite. Now let's look a little bit more into the future. What else can we do with this technique? Injecting medicines or vaccines will be a big achievement already, but we can also start testing this technology with other applications, for example, tattooing. Most people think of a tattoo as a drawing on an arm or a leg to mark an emotional event on the life of some people. But I am particularly interested in medical tattoos. For instance, covering scars or covering some parts of the skin that are different than the rest, or redrawing the nipple of a cancer patient after the nipple has been removed as part of the treatment. A tattoo can also be used to mark a specific body part of our body having a tumor. This helps the doctor to locate faster where the radiation or the medicine needs to be given. From an engineering point of view, tattooing is very inefficient. As you can see in this video, 50% of the ink is lost. Now, if you talk about some cheap ink, it's not a big deal. But if you're talking about an expensive medicine or vaccine, it is important to make everything get at the right spot and the right depth. Depending on the place of the tattoo, of course, it can also be painful. We are developing a technology that should be better than the conventional tattooing machines because we expect it to have no spilled medicine and should be also painless. To test our idea, we went again to the lab and see if this worked the way we wanted. If you tattoo with a needle, it looks like this. A large hole in the skin is left and causes inflammation and a wound, and that wound needs to heal with time. With our microjet device, it looks like this. A lot better, right? Note that there is no visible hole, and this is very encouraging because it means that you don't have to wait for the wound to heal. Finally, I would like to tell you about what our technology could mean for patients with insulin-dependent type 1 diabetes. As I told you before, fighting diabetes requires a lot of needles. The most advanced treatment nowadays uses a small patch on the stomach of the patient and a computer that is connected to a semi-permanent needle, and the patch will detect when the glucose levels are high, and a shot of insulin will be given through the needle in the patch. The main problem with this method is that the patch needs to be placed on a different spot of the body quite often, because if you leave it there for too long, it can bring worse problems. In the end, this constant replacement causes a lot of scars and inconvenience to the patient. If we could replace the needle in that patch with our jet injection device, this could solve plenty of those problems, such as the scars and the pain, and improve the quality of life of the patients. We started this lecture with the question, how can you get an injection without a needle? We learned that we can use small jet injections. I am really excited about this technique because the injection devices that we are building right now are getting smaller and smaller, and we are getting better at injecting the medicine in the right place while causing minimal damage to the skin. If we succeed, this will be a breakthrough in healthcare. I strongly believe that this technique will make all the people fearing needles very happy. With that, I'd like to thank you for your time.